Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Modal Interchange, and it's by GDC. Here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is this box in this case. We also have modular lines, where every run of 3 digits along a line contains a digit from 147, 258, or 369. So if you look at it, if you have a number keypad, if you look at it on the number keypad, you have the digits that are from 1 through 147, which are on the left side. You have the digits 2, 5, and 8, which are in the center, and the digits 3, 6, 9, which are on the right side. The thing is, though, these also form modulo series if you divide by 3, right? So if you divide 147 by 3, you get 1, a remainder of 1, which means that it's 1 modulo 3. If you divide 2, 5, and 8 by 3, you get a remainder of 2 for each of them, which means all of them are essentially in 2 mod 3. And if you divide 3, 6, or 9 by 3, you get 0 of a remainder, which means that it's 0 mod 3. So every 3 digits on a modular line must contain one set from 1 modulo 3, 2 modulo 3, and 0 modulo 3. And that's how modular lines work. You could have an example here, could be something like 5, 9, and 7. Because 5 is from 2 modulo 3, 9 is from 0 modulo 3, and 7 is from 1 modulo 3. So you have one of each in that set of 3 cells. And that's how modular lines work. We also have odd lots, where a circle digit counts the number of odd digits on its line. So if the circle digit is odd, it includes itself in the count. For example, I'm trying to find a 5 length. We don't have a 5 length one to match this. Say this was 4 and we added a different, let's say that we added extension here. Then if this were, say, 1, 2, 3, 4, and 2, this would be correct because there are only 2 odd digits on this line, right? Or if we had, I don't know, hard to get this. 2, 7, 1, 2, and 3. That's not right. 3 and 2. This 3 signals that there are 3 odd digits on this line, which there are, 7, 1, and 3. Anyways, that's how odd lots work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so simple thing is these odd lots can only be as large as the lines are long. Right? So this is 1, 2, or 3. This could be any digit 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these digits, though, are all in the same box. So there can be at most 5 odd digits in this set. Well, to add on, you could have 6 and 7 here. So this could be 1 through 7 here. And this is the same, right? We have 5 odd digits at most here. This could be 6 and 7 added on. So this is 1 through 7, possibly. This digit must be the same as this digit because they count the same amount of odd digits on this line. It could be 1, 2, 3, 4. I think it's the whole thing, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it could be the whole thing. We'll just mark this as the same digit. So it must be also one of these digits here. This could be 1 through 4 because the line is 4 in length. This is 1, 2, 3, 4, 5, 6. But there's only 5 in the same box, so this is 1 through 5. This is 1, 2, 3, 4, 5, 6, but same reasoning, this has to be 5 at most. Okay, and so these are modulos. Right, these are the same set. We're gonna start, yeah. We'll start coloring them in the same sets. So this is the same set as this, which must be the same set as this. This we're not sure of. We'll make that green and this orange. So these two must be different. All three of these are different sets. Therefore, what set are we missing here for this set of 3? It has to be green. Therefore, this is orange. This is orange because we're missing that from this set of 3, and this must be green. What does that tell us? I'm not really sure, but it tells us something. Modulo lines. These 3 have to be different sets. These 3 have to be different sets. Let's see. These 3 are different sets also. We're just gonna start randomly giving set colors. So this is light, medium, and dark, which makes this light, medium, and dark, which makes this light, medium, and dark. Okay, so we have 3. Okay, we have 3 medium grays here, and we have 3 dark grays here, which means the other 3 digits in this cage, or in this region, all have to be light. And so the light matches essentially green. So the light is green. This is also a green then. So this matches green and green. Green cannot be in the corner here. Okay, these must match similarly orange, right? This is not the same as these two. It has to be the same as these two, and therefore cannot be the same as these. Therefore, you'll have 3 from one set here and the 3 from the other set here. So these are all orange. This is orange, and this is orange here. That means we have a green, yellow, orange set here, because we have 2 greens, 2 yellows, and 2 oranges in row 4. What about these? I guess we'll make these blue and red. Make that blue, which makes this red. Therefore, this is red, this is blue, this is red, and this is blue. So orange matches either the light or the dark here, right? Green has to be one of these two. So we have 3 greens, we have 3 oranges in the row, so this must be yellow then. So this is yellow. We have a green, red, yellow here. So this is green or orange, we're not sure. Green, orange, yellow here. We don't know which one's which. This must be one of each. This cell matches none of these two, but it matches both of these. So this cell matches this one. We're not sure which. This cell matches both of these. Therefore, in this length 3 cell, it cannot be, it has to match the pink, right? So the pink cannot be orange here because pink matches either blue or red here. Hmm. This is one of each color here. This is one of each color here. So this must be one of each color here. So one of these is yellow. This is one of each color, one of each color. So it must be one of each color here. I'm just not sure how it matches. This is also one of each color, but we don't know how it matches. This is one of each color. This is one of each color, so this also must be one of each color here. Huh. That doesn't really tell us much, though. This is green. One of these two is green. Blue or red is green. And one of these three is green, so this can never be green. This is yellow or orange here. We're not sure which. Which means this is yellow or orange. Because it matches that one. These two, we don't know what they are. One of these is green. This can never be green. This is yellow or orange also. Right, because one of these two is green. This is green. One of these three is green. These are three different... Oh. So these are three different colors. These are the three different sets. These are three different sets. Therefore, these must be three different sets. So that's green. One of these is yellow. One of these is orange. We don't know anything about this, though. Right? What's the minimum amount here? So... the minimum here would be 3 odd digits, right? Because we have 2 digits here, which are from the same set, but that doesn't really help us much. But this is 1, 2, 3, 4, 5, 6, 7, minus 4 even digits, so it's 3 odd digits. So this is 3 at least. This is 3 at least. These must be different values. That's actually interesting. Oh, interesting. This can never be 1, 2, or 3, right? It's the same set as this, but it also sees that, so it can't be the 1, 2, or 3 from that. So this is 4 through 9 here. These, again, are different sets, so they have to be different numbers. Hmm. Oh, this can never be 4. If this were 4, the problem is that would be 3 odd digits plus itself, which would be 3 odd digits then. And that would not match. So this cannot be 4. It's 1, 2, or 3. Hmm. Mm-hmm. If this were 7, this could not be 7, so 7 would have to be one of these 2 digits, but then the odd digit would not be, they would not have 5 odd digits here. So this can never be 7. Could be 6 still, so it's 3, 4, 5, or 6. Hmm. Hmm. I guess we'll make this. Oops. We'll make this a different color, I guess. Oops. And the reds will make, I guess, at least these reds. We'll make light. This one, we have green, yeah, green, pink, yellow, red. We don't have another color. So I guess we'll just make it yellow, orange. That's fine. Okay, what else do we know about this? It can never be 8. If it's 8, the problem is that this would be 8, this would be 8, and then we would only have 7 possible odd digits left. So this can never be 8. This can never be 3. If this were 3, again, this is at minimum 3 odd digits in this box. And plus the 3, that makes 4. So this would have to be 4 through 6. Okay. That's interesting. So this is 4, 5, or 6 here. If this is 4, that means a 4 has to be one of these 2. So if this is 4, 4 has to be here, which means this is at minimum 4 odd digits, which would force that to be an even digit. So then this would be 4 also. That's interesting. So if this is 4, 4 has to be one of these 2. This is 1 or 7. We'd have 4 odd digits here, which means this is an even digit. the only even digit from 1 modulo 3 is 4, so that would be 4. If we had 5, that would mean this. So similarly, this is 4 if it's 1 modulo 3. If it's 5, that means this could not be 5. This would be 2 or 8. So they would, again, that would be an even digit. So you can only have one odd digit here. You would have one odd digit here. So this is 4 at most, which would make this an even digit. So again, if this is 5, this is odd. 5 has to be one of these. The other is 2 or 8, which means we have 4 odd digits here. So the 5 is odd. We have 4 odd digits here. That would make this an even digit. So this is 2 or 8. So this is the same reasoning. This is 2 or 8. If this is 6, a 6 would have to be here. The other one's odd. And I don't think that works. Right? If we have a 6 here, the 6 has to be here. The other one's an odd digit, 3 or 9. This is 4 odd digits then on the line. 6 is not an odd digit, so that's 4 plus at most one other one, which is not possible. So this is 4 or 5. This is 4 or 5. So we know orange has to be 1 modulo 3 or 2 modulo 3. And then green has to be 1 modulo 3 and 2 modulo 3. Therefore, the yellow must be 0 modulo 3. So that makes this 3. This is 6 or 9. This is 6 or 9. Which means this is 3 odd digits here. So these are all odd. That can be 1, 7, and it has to be 5. Because for the 2 modulo 3, the only odd digit is a 5. Therefore, this can't be 5. This is 4. So 4 must match with 4. The oranges then are essentially, the 1 modulo. So this is 5, which makes this 2 or 8 and 2 or 8 here. We have either 6 odd digits on the line or 9 odd digits on the line. We're not sure. This is 2, 4, 2, 5, or 8. This has to be 1 or 7. This is 1 or 7. This is 2, 5, and 8. And we have 2, 5, and 8 here. 2, 5, 8 here. This is 1, 4, 7. 1, 7. 1, 4, 7 here. This is either yellow or orange, so it's 1 or 3. Green is 2, 5, 8. This can't be 5. Aha! This is even. So since this is even, you cannot have 9 digits be odd on this line. So this must be 6. So this is 6, 6, which gives us 3 evens already on this 9-length line. So the rest must be odd. So this must be 5. This must be 5. This cannot be 4. Where's the 4 in this box? It must be here. So this is 4. This has to be 3 or 9 here. To be, so we have 1, 2, 3, 4, 5, 6 odd digits on the line. This can't be 5, so this must be then the 5 here. And this is green. So this is green. This cannot be green. This is orange. So there cannot be any more oranges in row 3 because we have a 1, 7, 1, 7 pair, and these can't be 4. So this has to be green and yellow. One is green, one is yellow. And this must, one of these must be orange with yellow. So we have orange and yellow here. 4 must be one of these two. We're not sure which. This can't be 5 here. This is either one odd digit or 3 odd digits. We're not sure which. Um, 4 is one of these digits here. 5 is one of these here. What are the remaining digits? Okay, so we have 5 is the 2 mod 3 here, and then we have 6 or 9 here. This has to be 1, 7 with 6 or 9 as the remaining digits here. Here we have 2 and 8 with 3, 6, and 9 here. We don't know which one's which. This is 1, 2, 3, 4, 5, 6, 7. So that means these could be 2 evens here, or it could be 0. So this is specifically 3, 4, 5. This could be, so this is 6 minus 4 is 2 at minimum. So this is 2, 3, or 4 here. Because it can't be 5. So 5 has to be one of these 2 digits here. 5 is one of these 2 digits here. Hmm. This must be the same digit as that one. Because we're missing a 1, 7 here in row 4, so it has to be here, which means it cannot be the other 1, 7. So this must be the same. Excuse me. So pink is not the same as orange. Because if you have 2 pinks here and 2 oranges here, and that would be 4 oranges then in the same column. So pink is either green or yellow, which means it cannot be 4 here. So it's either 3 or 5 odd digits here. But if it's 5, that would force these both to be 2 and 8. And we know 4 is already on that line. And that would break then. So this has to be yellow and 3. Right? Because, again, 4 is on this line because of normal Sudoku. It cannot be orange, so it can't be 4. And it must be 3 or 5. And if it's 5, these would then be 2 and 8 here. So we'd have an even, an even, and an even. That's 3 even. 7 minus 3 is 4 odds at most, which is not allowed. So this is, so these are all the yellows, and this must be 3. So since this is 3, this is 1. This must be, this can't be yellow. This is orange. This can't be yellow. This is orange. So this must be a 4 here. This cannot be 5. This cannot be, it's 3 or 9 here. We know this is 6 or 9. We have 3 odd digits, which means all the even digits are here. So these both must be odd. 4 is one of these. It must be, and then you have 2 and 8, I think, right? This is 1, which forces this not to be 1. So this is 7, this is 1. That makes this 1, so 1 cannot be either of these. 4 is one of these, so 7 cannot be here, right? So 7 has to be one or 7 has to be one of these. And this can't be 1. We have 3, a 9, and one of 1 or 7, which means this has to be 2 and 8 here. Which means 5 is one of these with 1 or 7. And this can't be 1. Both yellows are here, so this is yellow. This cannot be yellow here. It could be orange or blue or green, sorry. Which means it's 2 or 8, or it's 7 here. This is 1 odd digit on this line, so these are even. We need a yellow. This can't be yellow because it would be 9, so this would have to be yellow and a 6 here. This is green and 2 or 8. We're not sure which. This 6 eliminates 6 here, so this is 9, which makes this a 6. This 9 eliminates 9 here, so this is 3. This can't be 9. This can't be 6, so this is 3 or 9 here. Where is the 5 in row 6? It has to be here. So this is 5, which forces this to be 6. This can't be 6, so this is 5. The reds match the greens, so the reds are green. The blues match the yellows, so those are yellow. Therefore, these can't be 6. This can't be 3 or 9 here. This can't be 3 or 9. It's 2 or 8. This can't be 2 or 8. This can't be 2 or 8. This can't be 5, therefore this is a 1 or 7, which is orange. This must be then the green and is 5. So this is green or orange. This is green or orange. These are green or orange. This cannot be orange because we have 3 oranges here. This is orange, this is orange, this is orange, so this must be green. This is 3, 6, or 9. This cannot be 3 or 4, therefore it's a 2. And these must both be green, essentially. So this cannot be 5, it cannot be 2, it's 8 here, which forces this to be 2. This can't be 2 or 8, so this must be 4. This is then not 4 and is not orange. This is not green. We have orange and yellow here. This can't be 2 here. Where is the 2 in box 9? It has to be here. So this is 2. This is 8. One of these has to be yellow and therefore is a 3. One of these has to be 1, 4, or 7. We don't know which. One of these is a 3, though. So we have 1 odd here. We do not have a 5 here. We can't have 5 here, here, or here. So this must be a 5 here, which is green. This is yellow and orange, yellow and orange. One of these must be green, and it has to be 5. And 5 cannot be here, therefore 5 has to be here. Which makes this green. This is 6. Okay. This can't be 3 because of the 3 in the column. This can't be 3 because 3 in the column, so this is 9. Which makes that 6, which makes this 3, which makes this 9. This can't be 8. We have a 2, 7, 2, 7 pair here, which eliminates 2 and 7 from here. So this is 1, which makes this a 1. we have a 2, 7, 9 triplet in row 4. This can't be 2, though. This is green and a 5. 7, 8. This is green or yellow. This can't be 1, then. These can't be 6. So it's a 7, 9 pair here. 3 has to be one of these two. This 2 eliminates 2 here. Therefore, this is 8, which makes this 2. This 8 eliminates 8 here, so this is 2, which makes this 8, which makes this 2. That means this can't be 2. This is 7, this is 2. This 7 eliminates 7 here, so it's 1. This 8 eliminates 8 here, so this is 7. This is 8. Therefore, this is not green. This is orange. This is not orange. It's blue, green. No green, no orange. I mean, that means we are left with 1 here as the remaining orange. And 1 cannot be here, so this must be 1, which means this is not yellow. This is orange. This is not orange. This has to be not yellow, so this is not orange. Therefore, this is the 3. This is 4 or 7. We have 2 odd digits already, so this has to be the 4. This then has to be 6 to maintain the 2 odd digits, which is 1 and 3 here. That leaves this as a 7, 9 pair. This can't be 9 because of the 9 in the row, so this is 7, this is 9. 7 is orange, 9 is yellow. That leaves this as a 9. Oops. It's a yellow and a 9, which makes this 7 and an orange. 2's can't be 2 or 7, so this is 9, which makes this 2. This is yellow then, this is green. We have 1 and 8 remaining in row 7. This can't be 1 because of the 1 in the column, so this is 8, this is 1. That makes this orange, this is green. That leaves this as orange, which is 4. We have remaining here 3 and 7. Either of them could be there. Remaining here is 3 and 8. Either of those could be there. Remaining in row 4 is 3, 8, or 9. And this can't be 8 or 9 because of the 8 or 9 in the column. So this is 3. This can't be 8, so this is 9, which makes that 8. So this is yellow. We have yellow. And this is green. So no more greens left, but we already knew that. This 9 eliminates 9 here, so this is 7, this is 9. All the darks then are orange. And all the mediums are yellow. This can't be 6 then, this is 4, which makes that 6. This must be 1, and this must be 3 then. And now we have in row 2, 6 and 7 remaining. This can't be 6 because of the 6 in the column, so this is 7, this is 6, which means this is not yellow, this is not orange. The 7 eliminates 7 here, so this is 3 and, oops. This is 3, oops, 3 and 7 here, which makes this not 3, this is 8 and 3. We're left with a 2 here. This 8 is green, this 3, these 3s are yellow. And this is orange. We're missing a green here, so this can't be yellow, this can't be green. This must be the last remaining green is 8. This is 9. This is green, and we're missing orange here and yellow. No, orange here too. And it has to be 7 and 4. So that's 7 and 4. Pretty interesting, actually. Interesting how the odd lots worked with these modular lines, right? I particularly like this one right here. So finding out that the 4 couldn't be here because of this being the same set and these being the same set. And then the 5 not working because it requires a 2 and 8 with it. So that was really cool. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.